Today we're going to find greatest common factors and least common multiples using prime factorization and Venn diagrams. Before we do that though, let's look at the way that we have been using to find greatest common factor and least common multiples. Okay, to start off, let's do it the way that we are all familiar with, finding greatest common factor between 20 and 15 and then least common multiple. So we start by saying what are the factors of 20? One way that I've taught my students is to say, how do we get 20? So the first way we say 1 times 20, 2 times 10, and 4 times 5. Once we hit the turnaround where we do 5 times 4, we're pretty much all set. So the factors of 20 are 1, 2, 4, 5, 10, and 20. We do the same thing with 15. We say 1 times 15. There's no 2, and 3 times 5. So the factors of 15 would be 1, 3, 5, and 15. To find the greatest common factor, we would then circle the factors that they have in common, which is 1 and 5. Because we're looking at the greatest one would be 5. So the greatest common factor between 20 and 15 is 5. Now to find the least common multiple, we would look at the multiples of both 20 and 15. So 20 would start with 20, and then 40, 60, 80, and 100. And you could keep on going, but we try to stop and then see if we find the least there. So for 15, we would start with 15, 30, 45, and then 60. And usually we'd say, wait, I see one, and we would stop there. If not, we would continue and continue on. Since we do see one, we'll stop and say that the first one we come to, because it's the least, and the one they have in common, is 60. Therefore, the least common multiple between 20 and 15 is 60. Okay, so now let's look at another way of finding the greatest common factor and least common multiple. Let's start with prime factorization, and let's start with the prime factorization of 20. So 20 could be made by using 2 and 10, and 2 is a prime factor. It's a prime number, sorry. 10 can be broken down to 2 and 5. You notice I'm making factor trees here. 2 is a prime, and 5 is a prime. Now for 15, and that will be all we can do. We can't break down 2 or 5 anymore. 15 would be 3 and 5, and really that's it. And for those who get confused, it's 3 times 5. Both 3 and 5 are prime numbers. Now what we would do is we would draw a Venn diagram. If I make it here, I can make it small enough. There's my circle for 20, and here's my circle for 15. Now if I put in my prime numbers that are in both of them, to look at the one number that is in both of them, this is how we do this. They both have 5 in it, so if I cross out 5 for both of them, I only have to put it in one time in the middle. And the reason for that is because if you look at the 20, which is green, you'll see the 5. If you look at the blue one, which is 15, you'll see the 5 as well. So 20 is shared by both 5 is shared by both 20 and 15. Now, if we look at the other numbers, we could say that 20 also has a 2 in it and another 2. So we put those in there as well. And then we take the prime factor of 15 and we have a 3 left over. So we put the 3 in just the 15. So if you look at the circle, 15 has a 3 and a 5. And 20 has 2 2s and a 5, because that 5 is shared by both the 20 and the 15. Now here's the really cool part. The greatest common factor we'll fix that. The greatest common factor when you're using a Venn diagram is the numbers in the middle. If there's more than one, then you multiply them. Since there's only one, and it's 5, that is our greatest common factor. To find the least common multiple, all we do is multiply them straight across. So 2 times 2 is 4. 4 times 5 is 20, and that's our 20 there. 20 times 3 is 60, and lo and behold, here's our 60. And so that's how you use a Venn diagram. But don't take my word for it. Let's try another one. Okay, let's try some easy numbers, 12 and 10. So if we were to find the prime factorization of 12, we would start with either 3 times 4 or 6 times 2. I'm going to do 2 times 6. And 2 is a prime number, so I'm going to circle it, but 6 is not. 6 is called composite, so I need to break it down even more. 6 can be broken down into 2 times 3. And I think that's it, because I can't break it down anymore. So my prime factorization for 12 is 2, 2, and 3. For 10, it is 2 times 5. And 2 is prime, and 5 is prime. So I'm all set. So now if I were to draw a Venn diagram, there for my 12, I'll make my 10 blue. And if I look at the numbers they have in common, it looks like 2 is the one number they have in common. They both have a 2 in it. Notice that there are 2 2s, but I'm only writing it one time. And then if I look again, there's a 2 and a 3 left over for the 12. So I'll write them in there. And for the 10, there's only a 5 left over. So, according to my new way of finding things, the greatest common factor becomes the numbers in the middle. And if there's more than one, we multiply them. Since there's not more than one, we're just going to write 2. And the least common multiple is when we multiply them all together. 2 times 3 is 6. 6 times 2 is 12. And then 12 times 5 is 60. Remembering, of course, if you're not sure about that, you can do 12 times 5 on the side and get your 60 that way. Okay, let's try one more and see if we can get 2 numbers in the middle so that you can see what that will look like. Okay, let's look at 15 and 45. So 15 can be broken down to 3 times 5. Both numbers are prime, so we'll circle them. And 45 can be broken down to, first, 3 times 15. 3 is a prime, 15 is not. 15 can be broken down to 3 times 5, though. And now we have all prime numbers. Okay, so now if I draw my Venn diagram, with 15 here, and 45 here, if I look at the numbers that they have in common, well, they both have a 3. So I can put a 3 in here. And they both have a 5. So I can put a 5 in here. Which leaves 15 with nothing else. So I don't have to put anything else in here. 45, though, has a 3 left over. So I can put that in here. So now, my greatest common factor, if I were to go in here, will have to be 3 times 5, which is 15. And my least common multiple will be 3 times 5, which is 15, and 15 times 3, which is 45. Now, if you want to just check to make sure we did this all correctly, we could put the factors of 15 over here, the older way. 1 times 15, 3 times 5. Factors of 15 would be 1, 3, 5, 15, 45. 1 times 45, 3 times 15, and I knew this, 5 times 9. And then we would put them as 1, 3, 5, 9, 15, and 45. Again, the greatest common factor would be 15. They both have 5 as factors, and 3 and 1, but the greatest one is 15. And there it is. For the LCM, we would put 15, 30, 45. Wait, we already know. If we put 45 out, it starts right there. So that would be the least common multiple. So no matter how you do it, it can be done, but if you want to do it the faster and easier way, it's probably best to go ahead and use our Venn diagram. I hope this was helpful and that I didn't make too many mistakes in explaining it. Thanks for watching.